In the previous episode, we presented a scientific argument supporting three key claims made by Bob Lazar. In this episode, we travel beyond Bob's claims, to offer a possible explanation for the physics underlying specific capabilities. We shall discuss two fundamental questions. Number 1, how does the spacecraft hover at the surface of the Earth? And number 2, how does its interstellar capability operate? Before we commence, I must strongly emphasize that we are offering possible explanations only, not experimentally verified fact. The content of this video presentation is conjecture, and should be considered as such. Okay, let's move forward. The first thing we're going to do is eliminate what isn't possible. We know that interstellar travel is required, but we also know that faster-than-light travel introduces paradoxes, and therefore, isn't possible. Please take the time to follow the link shown, and watch the video. It shows that all forms of faster-than-light travel are impossible, and the authors of the video have done an excellent job presenting the evidence, using only space-time diagrams. So, if faster-than-light travel isn't possible, interstellar space travel is also impossible, right? No. Another possibility exists, and we'll look at that a bit later on. But for now, let's look at a possible explanation for the physics of hovering at the surface of the Earth. In the previous episode, we derived the value of gravity A wave pulse frequency claimed by Bob Lazar, almost precisely. Lazar claims a value of 7.46 Hz, and we calculated a value of 7.43 Hz. It's important to understand that the gravity A wave pulse frequency is equal to the sum of the first 415 modes of the gravity B wave environment. To describe the situation simply, element 115 atoms naturally generate an electromagnetic-like signal at 11.44 GHz, which is amplified, then pulse released at a frequency matching the gravity B environment of the Earth, and phase shifted as required. We expect this phase shifting to be 180 degrees. Let's now revisit episode 6. We need to do this in order to explain the way element 115 may be enabling the hovering function at the surface of the Earth. In the bottom left-hand corner of this illustration, we see the quantum potential energy associated with the zero-point field. The zero-point field is the physical manifestation of the quantum potential energy released into the physical universe when the quantum vacuum is in its ground state. We manifestly observe this process in the Casimir effect. The illustration depicts the amplitude and frequency spectra associated with the available quantum potential energy, formatted in accordance with a Fourier distribution. As described by the unit harmonic operator in episode 2, each wave function denotes a population of virtual photons and exists in conjugate pairs, as indicated and required for net zero gain. Hence the term, zero point. These wave functions mean that at any instant in time, populations of virtual photons pop into existence, but so do an equivalent population of virtual photons, 180 degrees out of phase. Consequently, no electromagnetic radiation is ever experimentally observed, mysteriously appearing from nowhere. The amplitude of each wave function denotes the probability of a population of photons popping into existence. As you can see, the probability of emergence into reality is significantly greater at lower frequencies than it is at higher frequencies. That is, the higher up the frequency spectrum we look, the lower the probability of virtual photons popping into existence. And as we have already established, for perfectly flat space-time geometry, the harmonic cutoff frequency tends to infinity. This also means that its probability amplitude tends to zero. In other words, it is impossible for photons of infinite frequency to exist in the physical universe. Hence, the universe cannot catastrophically collapse. So, what have we achieved with this explanation? Well, we have described the virtual photon creation and annihilation process occurring in the quantum vacuum at the surface of the Earth. But this is only half the story. Now, we need to consider and describe what the Earth is doing to the quantum vacuum. When we add matter to the zero-point field, a major change occurs. The quantum vacuum becomes polarized by the presence of matter and compresses the frequency range of the zero-point field. The lower spectral frequency limit is upshifted from 0 Hz, and the upper spectral limit is downshifted from infinity. Both alternate spectral limits are mass-energy dependent. However, the structural format of the Fourier distribution is preserved. In other words, the mathematical description doesn't change, the Fourier distribution is preserved, but its lower and upper frequency limits have been modified, due to the addition of matter. We call this polarized form of the quantum vacuum, the polarizable vacuum, and is represented by the gravitational harmonic operator appearing in the bottom right-hand corner of the screen. To express what is happening in simple terms, the Earth is radiating gravitons and the quantum vacuum is absorbing them. So, how does all of this explain the way element 115 may be enabling the hovering function at the surface of the Earth? Let's have a look. In this frame, we see that when the amplitude and frequency spectra are summed, we obtain the unit harmonic operator. However, what is important to recognize is that the amplitude spectrum depicted represents two physical and simultaneous processes. The first process relates to virtual photon creation annihilation at the surface of the Earth, that is, the probability of at least one virtual photon popping into existence at each harmonic. The second process relates to the proportion of gravitons radiated by the Earth, being absorbed by the quantum vacuum at the surface of the Earth, at each harmonic. We can see from the harmonic examples that probabilities in proportions are maximal at low harmonics, and minimal at high harmonics. In the next slide, we'll look at what this means with respect to element 115. By targeting the 415th harmonic, all harmonics from 1 to 415 are interfered with due to the Fourier summation process associated with the unit harmonic operator. Therefore, with the appropriate phase shifting of the amplified element 115 signal, three possibilities exist. Number 1, all gravitonic wave functions, from the first harmonic to the 415th harmonic, experience destructive interference, thus preventing quantum vacuum absorption of radiated gravitons and consequently, disrupting the space-time curvature associated with general relativity. Number 2, all virtual photon creation annihilation events experience destructive interference and disrupt the Casimir effect. And number 3, both of these mechanisms occur simultaneously. Therefore, what is our conclusion? Well, since the space-time curvature associated with general relativity, and the Casimir effect, cannot be dissociated from one another, element 115 must act as a quantum vacuum inhibitor, by disrupting the wave functions illustrated on screen. This means that, in principle, during hovering tests at the surface of the Earth, observers may be able to detect a dim low-frequency hum at 7.46 Hz, when utilizing the appropriate detection equipment. The lower frequency limit of human hearing is approximately 20 Hz, so it is probably unlikely that humans will be able to audibly detect this dim hum, without the assistance of technology. However, it may be possible to feel this noise in one's body, much like a subwoofer. Next, we'll look at a possible explanation for interstellar travel. On slide 2, we presented evidence created by others, clearly demonstrating that faster-than-light travel of any form generates physical paradoxes. Hence, the concept of faster-than-light travel may be dismissed as nonsense. Importantly, the creators derive this conclusion utilizing space-time diagrams, so the method of faster-than-light propulsion is irrelevant. If faster-than-light travel is physically impossible, could wormholes be possible instead? Unfortunately not. Wormhole travel introduces the potential for paradoxes as well. How so? Well, in the video created by the Cool Worlds team, they allow for instantaneous travel too. This is pretty much what wormhole travel is equivalent to, instantaneous faster-than-light travel. Hence, it is also impossible and can be dismissed as nonsense. So, where does this leave us? Well, unfortunately, it doesn't leave us in a good place. All we can do is wishfully assume that the physics of today doesn't have all the answers and some room for movement exists. This is why the solution for interstellar travel presented in this episode is pure conjecture, and open to refutation and correction. Having said this, let's take a crack at it anyway. In our attempt, we'll approach the problem in a new way. Throughout numerous episodes, we have proposed the concept of the Big Bang singularity. This is not a new idea, but we have given it new life. I would encourage viewers to review our video titled, History of the Cosmos, which was presented at a conference hosted by CERN in December 2022. In our presentation, we showed that the Big Bang singularity remains a valid proposition, despite contemporary assertions contesting this. The significance of this is that, at momentarily prior to the Big Bang, every point in the universe was, simplistically speaking, co-located. We have also propositioned in episode 6, that the zero-point field denotes a dark reservoir of quantum potential energy. Hence, combining the concept of a Big Bang singularity with the quantum model of cosmology, we propose that any 2 points within the quantum vacuum which are in precisely the same energy state, will be separated by the distance as occurred at the instant of the Big Bang, that is, no more than the singularity radius appearing on screen. This may not be as bizarre as it sounds. The Large Hadron Collider in Switzerland have claimed to have reproduced the conditions of the Big Bang, but fleetingly. If true, then they have made our point for us. It becomes entirely conceivable that element 115 as an energy source, could be capable of this, or indeed, much more. Let's try to visualize what we mean. Let's begin by considering the concept of gravitational equipotential. In this illustration, we see the Earth from space. The polarizable vacuum field is the polarized form of the quantum vacuum. In other words, the polarizable vacuum field is a quantum vacuum representation of the curved space-time associated with general relativity. The dotted line represents an arbitrary orbital radius. Every point along this line is at the same gravitational potential. This means that, in a manner of speaking, every point along the line of equipotential is the same point. Hence, in a manner of speaking, a satellite traveling along the orbital circumference hasn't moved at all, only time has passed. Let's now look at a space alien civilization, perhaps 39 light-years from Earth. Let's also assume that their home planet had the same mass as Earth. If the Martians were visiting Earth and wanted to go home for dinner, how might they be able to do this with element 115? If they wanted to travel from point A to point B, then in some sense, these 2 points are co-located because they're at the same quantum potential with respect to the quantum vacuum. So, if these 2 points are at the same quantum potential, as a consequence of quantum vacuum polarization induced by the presence of planetary matter, what lays between them? That's easy to answer, the dark reservoir of quantum potential energy. The dark reservoir of quantum potential energy is represented by the ground state of the quantum vacuum, termed the zero-point field. This means that between point A and B, exists a randomized effervescent field of virtual photons popping into and out of existence. This is also known as the Casimir effect. If element 115 acts as a quantum vacuum inhibitor, and can eliminate the Casimir effect between 2 points in space-time, it may mean that the space-time between these 2 points collapses, so that the endpoints become, effectively, co-located. As was the case momentarily prior to the Big Bang. This means that, at most, the space-time between A and B is no more than approximately 12 femtometers apart. This is not to say that a wormhole has formed between these 2 points, we mean to say that they are almost literally the same point in space-time, as might have appeared momentarily prior to the Big Bang. And, as we know, creating Big Bang conditions is possible, as claimed by the team at the Large Hadron Collider in Switzerland. So, what rules can we infer from this conjecture, in order to avoid paradoxes? Let's discuss this on the next slide. Let's begin by looking at the change in the quantum vacuum from the Big Bang to the present day. We know from claims by the Large Hadron Collider team in Switzerland, that reproducing the conditions of the Big Bang have already been experimentally accomplished. The fact that humanity is able to achieve this, at our current level of technology, is a guarantee that a more advanced civilization elsewhere in our galaxy, must also be capable of similar achievements. However, the claims of Bob Lazar permits the latitude for space alien Martians, to accomplish this, but without a particle collider and in a more efficient manner. Perhaps they have achieved this utilizing element 115? If so, we propose that element 115 acts as a quantum vacuum inhibitor, collapsing space-time between 2 points by destructively interfering with the Casimir effect. This, in effect, achieves a similar outcome to the Large Hadron Collider team in Switzerland by reproducing a geometric attribute of the Big Bang, but at a micro scale. Since no 2 points in space-time can ever be determined to exist in exactly the same state at the same instant, as inferred by the Heisenberg uncertainty principle, the natural connection of points can only ever have occurred once in the history of the cosmos, that is, at the instant of the Big Bang. However, perhaps it is possible to connect 2 points utilizing element 115 technology by inhibiting quantum vacuum probabilities. However, this would also come with its own set of difficulties. For example, the quantum vacuum state of the target destination would be required knowledge. Hence, polarizable vacuum-structured environments, such as planetary gravitational fields, might be preferred. Random quantum vacuum environments, such as free space, may not be desirable or possible. But that's not all. In order to avoid paradoxes, time may need to dilate across the throat of the bridge. Thus, some of the rules required in order to avoid paradoxes might be: number 1, only one-way travel is possible, that is, in the direction of motion. Number 2, time dilates for non-local observers, as if the distance A to B was being traversed at near the speed of light, hence, no time paradoxes. And number 3, the entropy of the universe continues to increase due to natural cosmological expansion. So, if points A and B are separated by 39 light-years, the journey home for the Martians aboard the spaceship will appear almost instantaneous, as if stepping through a doorway, but to observers on Earth, approximately 39 years will have passed. Of course, as we stated at the very beginning of this presentation, this is all purely conjecture and may be completely incorrect. Moreover, criticism of our solution should be tempered by the fact that all forms of faster-than-light travel, including wormholes, have significant paradox issues of their own. Therefore, the solution we have presented is no worse than any existing proposition, including those presented by Nobel laureates. Is time travel possible? This has been the subject of many Hollywood movies. So, is it possible? The short answer is no, it isn't possible, but why not? The reason is attributed to a concept termed the arrow of time. This means that the entropy of the universe is always increasing and can never be reversed. Entropy, don't forget, is a measure of disorder. Hence, the disorder in the universe is always increasing. But can we demonstrate this? Yes, we can, by calculating temperatures. If you recall episode 11, you'll recall that we derived an expression for cosmic microwave background radiation temperature, which precisely matched experimental observation. However, let's put that aside for now, we'll come back to it in a moment. Let's take a look at black hole temperature. If we calculate the temperature of a black hole of cosmological mass, we obtain a value of approximately 10 to the minus 30 Kelvin. This means that if we could compress all the mass energy within the entire universe into a single clump of matter, it would register on our thermometers as very cold, but not absolute zero. This is extremely important, and I'll explain why. When we execute a calculation for the cosmic microwave background radiation temperature, at the instant of the Big Bang, by substituting H sub alpha into our episode 11 experimentally verified equation, we obtain a value of exactly 0 Kelvin, or in other words, absolute zero. Therefore, because our Big Bang cosmic microwave background radiation temperature is different from the black hole temperature, the concept of the arrow of time has been proven, and that time travel isn't possible. If it were possible, then the black hole temperature equation would yield a value of absolute zero too. So, what is Project Looking Glass about? Project Looking Glass comes from a report by Bob Lazar, that the United States government was conducting potential time travel experiments at their S4 facility. However, as we established on the previous slide, time travel is a physical impossibility. So what could Looking Glass have really been about? And what may any experimental results collected actually lead to? To answer these questions, we firstly need to appreciate that gravitational fields affect the rate at which time passes. This is not new, this is standard physics. This is one of the primary conclusions of the theory of general relativity. Let's imagine that element 115 is utilized in an apparatus on a benchtop experiment, in order to reduce the local value of gravitational acceleration from 9.81 meters per second squared to 0. Let's also imagine that the apparatus produces an effect with a 1 meter radius. Now, let's place an atomic clock within this element 115 field. Before we did this, we made sure that it was synchronized to an equivalent atomic clock, 10 meters away from the field. So, we have two atomic clocks. One inside the field, one outside the field, both of which have been previously synchronized. If we wait a while, then compare the time passed on both atomic clocks, we find that more time has passed for the atomic clock which has been immersed in the element 115 field, compared to the atomic clock which remained outside the element 115 field. This means that, from the perspective of the observer outside the element 115 field, the difference in time between these two atomic clocks is negative. A negative time difference implies time travel, but that's not actually the case. So what really happened? Well, the surface of the Earth is actually a gravity well. This means that clocks tick more slowly than they would in free space, millions of kilometers from any celestial body. Hence, the element 115 apparatus flattens space-time, mimicking a zero-strength gravitational environment. Consequently, the atomic clock inside the element 115 field ticked more quickly than the atomic clock outside the element 115 field. This is what produced the negative time difference. You can see the illusionary time travel calculations in the bottom right-hand corner of the screen. The values shown are the maximum gains possible at the surface of the Earth. Notably, the maximum advantage after 1 hour has passed outside the element 115 field is approximately 2.5 microseconds. This isn't much of a difference, but in terms of potential quantum computing applications, it might as well be billions of years. Imagine the trillions of calculations more that your quantum computer can execute over your enemy's equivalent machine if you always had a 2.5 microsecond advantage. This computational advantage has nearly limitless military applications. Moreover, this computational advantage is future-proof if your enemy doesn't have access to element 115. Therefore, it is not surprising that the US military may be interested in weaponizing this capability. Let's look at the potential quantum computing advantages a little more closely. Firstly, let's imagine that quantum computers have been shrunk down to the size of transistors, just like we've seen happen in the past. Let's now imagine that a population of quantum computers will be shrunk down, in the not-so-distant future, to fit into a box the size of a personal computer. Technological shrinking has happened in the past, so it can happen again. Now, consider if 1 billion quantum computers can fit into the desktop box. This means that the 2.5 microsecond advantage described on the previous slide, per quantum computer inside the element 115 field, swells to almost 42 minutes for the entire population of quantum computers working on a single problem for an hour, as shown by the calculation. Hence, the advantage to military intelligence is clear and obvious. In this episode, we have covered the two objectives stated in the introduction. That is, we have presented a possible explanation for the manner in which the hovering function of the sports model at the surface of the Earth, as described by Bob Lazar, may operate in terms of physical principles. We also addressed the function of interstellar travel and offered a novel explanation for its operational principles. Moreover, we also provided a possible interpretation of the so-called Project Looking Glass. However, once again we stress that the contents of this episode are purely conjecture. The conclusions presented may be incorrect, so viewer discretion is advised.